welcome to Space with Sarah. Have you ever thought about how we know that black holes actually exist? First of all, let's start with a definition of a black hole. A black hole is something so small and massive that even light, which travels faster than anything, cannot escape from it. Imagine we're trying to launch a rocket off of Earth. We want it to completely escape Earth's gravity, not just go into orbit around Earth like a satellite. Based on Newton's law of gravity, we would use this equation where g is the gravitational constant, m is the mass of the Earth in this case, and r is the radius of Earth. The escape velocity away from an object depends on that object's mass and radius. The definition of a black hole is simply that the escape velocity of this object is greater than the speed of light. That means that the mass is so big and the radius is so small that nothing can escape it, not even light. You might say then, but wait, light particles, or photons, don't have mass and a rocket does. How is light affected by gravity? And that question is valid. Photons don't have mass, but they do have energy. And according to Einstein, mass and energy are equivalent. I won't go into the details of general relativity here, but basically both energy and mass are affected by the fabric of space-time. My favorite experiment related to black holes is the experiment done at the center of our own galaxy, except for maybe the recent detection of gravitational waves, but that's for another video. For more than a decade, a group of researchers have traced the motion of several stars orbiting our own Milky Way's galactic center, which is roughly 26,000 light years away from us. Essentially, what we're seeing are all these stars orbiting nothing, and they're all on different orbits with various paths. Using Kepler's law, we can quite simply determine the mass that's pulling all the different stars around in their orbits. We can do this by looking at the size of the stars' orbits and how long it takes the stars to complete one orbit. Doing this analysis on all the stars they have observed in the center of the galaxy, they found that the stars are orbiting some object with a mass of more than 4 million suns. For comparison, the whole Milky Way galaxy has roughly 100 billion stars, so they are much more gravitationally significant than the black hole in the center of the galaxy. This means that the black hole is not causing the rotation of the Milky Way, which is a common misconception. Also, this black hole is not going to suck everything into it, as its gravitational effect falls off rapidly with a distance from the black hole. This is a pretty massive object located right at the center of our own galaxy. And so far, there's no explanation of it being anything other than a black hole. For example, we would be able to see a giant star cluster with 4 million stars like the Sun. It turns out that all Milky Way-type galaxies, and also what we call elliptical galaxies, have very massive black holes at their centers. It's still an open question and an area of active research how these black holes can form, and especially how they can form so early in the history of the universe, which we can detect in distant galaxies. Thanks for watching Space with Sarah. If you're still curious about the universe, please subscribe to the channel, and as always, keep wondering.